Guys, today we want to see risk neutral valuation of options. Let's get started. One of the major concepts in valuation of derivatives is risk neutral valuation. It is like the value of one price. The law of one price states that if two investment have the same cash flows at same times in future, then they should both sell at same price. So it is based on risk neutral valuation. It is kind of a risk-free rate valuation, and this same concept is also being used in binomial trees, assuming that the market participant expect return at risk-free rate. So that is the expectation from the market participants, and this is being used in binomial trees also, and it is also being used in investment valuation as well. So the one-step binomial model can be expressed in terms of probabilities and call prices. So probability is being calculated by this formula, e raised to rt minus d divided by u minus d. The other probability of downstate is obviously 1 minus the probability of upstate. So upstate, the moment size of up move u is calculated by e raised to sigma into root t, where sigma is the volatility and root t is the length of the time in which the binomial tree operates. So d is 1 by u. So these are the factors that we need to consider by valuing in under risk neutral valuation. With an example, we'll see how it goes on. So guys, consider this example. The current price of downscale key excipients is incorporated is $20. The annual standard deviation is 14%. The continuously compounded risk-free rate is 4% per annum. Assume downhill pays no dividends. Compute European option 1 year. Strike price 20 using a 1 period binomial model. So the problem with this binomial model is that it has not given us upstate and downstate value. So first we'll have to compute that, and the percentage means percentage of probability of upstate and downstate also it is not given. So we'll have to find out both. So upstate, where we have a formula u is equal to e raised to sigma into root t, that will give us upstate value. So and downstate value will be 1 divided by u. So value of u is equal to 1.15 as computed, e raised to 0.14 into root 1, and d is equal to 1 by 1.15 is equal to 0.87. So multiply this with the our current stock price, we will get the upstate value, and multiply d with our current stock price, we will get downstate value. So we will have to calculate the probability at upstate and probability at downstate. Probability of upstate, will have the formula e raised to rt minus d divided by u minus d, and for downstate the probability is calculated by 1 minus upstate probability. So while putting in the equation, e raised to 0.04, which is a risk-free rate, into 1, which is time period, minus d, which is 1.15, u is equal to 0.87 minus d, u is 1.15, d is 0.87, which gives 0.61, and the rest probability of downstate will be 0.37. So then we'll have to find out the stock value and option value, as we have to assume a portfolio with stock and option so as to value the option. So for the stock, 20 will go up to 23 and it will go down to 17.4 as calculated by our d and u values. And for binomial tree option, if the option goes up to 23, the value of the option is 3, and if it goes down to 17.4, the value will be 0. So expected value of the option in 1 year is 3, which is 23 minus 0 into the probability 0.61 plus 0 into 0.39%, which will give us 1.83. So at year 1 the value of option is 1.83. So we'll discount it back to year 0, which is 1.83 divided by e raised to 1.04 into 1, which will give us 1.0408, which is 1.76. So value of the present value of the call option now today is 1.76. This is how we value using risk neutral model, which is pretty straightforward. Hi guys, if you like my video, like, share and subscribe. If you have any suggestion, please comment. Thank you.